Okay, so now that we've discussed petrodiesel and biodiesel, now we're just going to go into comparing them. And this is really where the money is, so to speak, when we talk about the VCE Chem exam. A lot of times you'll be asked to compare biodiesel and petrodiesel, and especially in the context of biodiesel's appropriateness as a fuel in different contexts. So there's four main points I want to discuss in comparison. And we're going to talk about these in sort of general terms rather than using numerical values or quantitatively comparing them in that sense, because oftentimes in a question you will be asked to compare these two in a qualitative sense rather than a quantitative sense. So the first thing is that petrodiesel has a slightly higher energy content and energy density than biodiesel. Now, on the surface, this seems like just a straight win for petrodiesel, for those in the petrodiesel camp. But this is sort of offset mainly because this energy content the difference is very small in the grand scheme of things. But it's also because biodiesel it burns more efficiently and it burns cleaner, and that almost offsets the increase in energy content that petrodiesel has. But it's still worth noting. It's still relevant enough to note. Two, biodiesel has a really high viscosity, and when we compare that to petrodiesel. Now, the reason why is if you had a look at the structure of biodiesel, you know how I mentioned multiple times that it is a fatty acid ester. So as a result, if we look at an ester linkage here, the oxygen in this arrangement is highly electronegative, and carbon is more electropositive. So that means that in this covalent double bond, and that will also be the case here, in this covalent double bond, most of the electrons are spending time closer to the oxygen rather than with the carbon. And that the same sort of process goes over here. The oxygen is sort of hogging the covalent electrons that are being bonded together. And as a result, this attracts other sort of polar molecules, so things like water. So if we draw the structure of water, the oxygen is electronegative in that case as well, and the hydrogen is electropositive. So this sort of dipole-dipole interaction is the intermolecular bond that is occurring here. And so you would have learned about this in year 11, of course. And so this sort of interaction here leads to stronger interactions between also other sorts of other ester linkages within a sample of biodiesel. So if we had another ester linkage here, you could see how this electrostatic attraction could lead to a dipole-dipole interaction. And vice versa, you can see how it could bond on the oxygen side to the carbon side to the oxygen, etc., etc. And so these strong intermolecular bonds means that the viscosity, and for those who don't know, viscosity is basically just resistance to flow. So let me just write that here: resistance. Oh, I've spelled that wrong. Sorry, resistance to flow. And so if you have these really strong intermolecular bonds with biodiesel compared to the petrodiesel's non-polar dispersion forces, it's going to be really hard for the biodiesel to sort of flow, especially if we have like a pipe here, to float along these pipelines, because they're going to be attracted to each other and they're not going to want to sort of slide past each other, which would be required for them to flow smoothly. Now, moving on as well, if we go down here, this sort of ester group linkage that we talk about with biodiesel also means that biodiesel is hygroscopic. Now, what hygroscopic means essentially is it attracts or absorbs water. So if you exposed an example of biodiesel to the atmosphere, it would absorb a lot of that water in the atmosphere, and especially in cold or humid conditions where there's water in the atmosphere, or there's water around as ice or frost and things like that. It's going to absorb a lot of that. And so the final point I want to say is the combo of this hygroscopicity and the high viscosity means that biodiesel has a high cloud point. Now, so what that means is that when we discuss sort of the usage of biodiesel in cold conditions, so what cloud point essentially means is that this is the lowest temperature at which crystals form. And in the context of practical usage, if you have a high cloud point, it means that if you're operating in cold conditions, you're more likely going to cloud up, so to speak, and essentially clog up the fuel lines, clog up the engine, because the substance is turning from a liquid more towards a solid. So what happens is the high viscosity means that the biodiesel is very stagnant. So if we compared, say, let's not use it like that. Say if we compared these two pipes, right? And this has petrodiesel and this has biodiesel. This is going to flow very slowly. But this might flow a lot faster. The liquid's going to pass through each other. It's not going to remain stagnant and in one place. But with this context here with biodiesel, the liquid can stay in one place, absorb the water from the atmosphere through whatever, if you open the fuel tank or things like that to fill it up and things like that. It absorbs the water and it means that it can sort of stay there, cloud up. The water can freeze as well because the cloud point for biodiesel is roughly from anywhere to like 5 to negative 10 degrees Celsius. So in that sort of water freezing temperature. And when we compare that to petrodiesel, which is more towards like 2 to negative 15 degrees Celsius, this is just higher. So the water can freeze over, the biodiesel can remain stagnant and sort of clump up. And then you have this point where it just becomes a crystal, it becomes sort of a solid. And that's really important when we talk about its use in cold climates. So obviously people in cold climates or contexts where you are going to use a fuel in cold climates, you're going to probably prefer petrodiesel to biodiesel, simply for this fact that you run the risk of using biodiesel, if you use biodiesel, of clogging up your engine, and that's a very expensive risk to take. So that's another consideration you need to know when considering using biodiesel. Okay, so we're going to finish up with discussing the environmental considerations. So we're just going to keep this pretty straightforward because a lot of the environmental considerations we talked about in the last video apply to biodiesel and petrodiesel. Essentially, it comes down to petro is a fossil fuel. So it's going to be unsustainable for long-term use into the future because it's a non-renewable fuel. And the other problem with it is that it releases more particulates. So these are things like, sort of sulfur particulates, nitrogen particulates, soot, carbon, etc., heavy metals possibly as well. It releases more of those particulates and carbon emissions just outrightly compared to biodiesel. But, one could argue because it has a bit more fuel content, so energy content, energy density, you might need to use less petrodiesel than biodiesel. But overall, it still releases more of those emissions. And with biodiesel, it kind of comes down to those things we were discussing last video with sort of how you source it. So it's renewable, obviously, so that's one positive. But the problem with it is, if you use intensive farming, intensive farming practices or switching over from food production to fuel production, that can also lead to issues down the line with land degradation, water shortages, etc., etc. And like we talked about bioethanol, if you have supply chain issues when it comes to farm machinery, that can also lead to CO2 emissions. But the main fundamental point you need to remember is that obviously any emissions from combustion is slightly, or substantially I should say, is offset by the carbon that is absorbed by using plants. Obviously, plants absorb carbon dioxide from the atmosphere in the form of photosynthesis. And so that's a really key point and a really key positive when it comes to using biofuel, especially if we look at it strictly from an environmental and emissions point of view. So that's all. Thank you for watching the video, and I hope you like it. If you did, check out the other videos that I've made. And yeah, have a good rest of your day.